All right, so last time I think we were looking at lab 2. And we did this unit conversion problem, which was a little complicated. We also did this other problem on generating random numbers. And I mentioned about preparing for the exam. And that problem, exercise 2, is like a sample exam. It's a previous exam that I gave in this class. So you need to start practicing to get ready for that. And the key to doing well in the class is to practice. So I give you lots of opportunity to practice. And make sure that you make an honest effort at practicing. You know, if you copy your work from someone else, you're not going to do well in the exam because you're not getting that practice. So you need to practice, and maybe I'll take questions on this now. If anyone has already started this and has questions about how to analyze these problems, is there anybody want to pick one of these?
7.
Number 7. Write a C++ program that computes the sum of integers 0 through n, where n is an integer entered by the user. Okay, so now this is an exam question. So you would write this out, you know, with a pen or with a pencil on your exam paper. Now look at the way I wrote that. Write a C++ program that computes the sum of integers 0 through n, where n is an integer entered by the user. Let's call this, I'll go into lab 2. And we'll call this exercise 2-7. So there's some input. We read in a value n. Actually, if you omitted that, it would probably be okay. So we're writing a program where our user enters an integer n, and the program needs to compute the sum of 0 plus 1 plus 2 all the way up to n. So what we do is declare a variable, I'll call it sum, and I'll initialize it to 0. And what we want to do is add the values, let's add. We declare this sum. It's a variable. We initialize it to 0, and then we add in the values 0 through n into sum. And then we print sum. Actually, if you omitted this and omitted this, it's okay. But this is the key part here, is the algorithm part. So we declare a variable sum, initialize it to 0. So how do we add these values into that variable? Well, it's a loop, right? So we have to repeat something over and over again. And we don't know exactly how many times the loop is going to run because the number of iterations depends on n, the number entered by the user. So let's create a loop. We'll use I as a counter inside the loop. Initialize it to 0. There's a loop condition which something that makes the loop stop working. I will use mine. Okay, so what we do is we take sum and we add into sum the value I. So I is going to be incremented inside this loop. We start at 0, then I becomes 1, then 2, then 3, like that. And then we want to finish this loop with we want the loop condition to become false when we're done. So what would that loop condition be?
I is less than or equal to n.
Yeah, that's good. I less than or equal to n. Very good. Because we want to include n. Actually, I don't say that here. I say 0 through n. I could have used the word inclusive to say make sure you include the n. So that's it. The key parts: declare this accumulator variable, this variable that accumulates the sum. I call it sum, but you could call it something else. You could call it, say the result. Any questions? How about some other problem anyone wants to look at? So it won't be very useful unless you've struggled with these first. You got to work on these on your own. Okay. Yeah.
Number 3. Just want to know what that is.
Number 3.
Yeah.
How many times? Here it is, right here.
Oh, number 4. My bad.
Four.
4.
Right there. Okay, 4.
Figure 4 is above.
Oh, sorry. There we go. This is figure 4 here, which is right there. And problem 4 is asking about figure 4. When the code in figure 4 runs, what does it output to the console? So let's see. How do we analyze this? Well, I'm going to copy this over here so I can do some writing. Actually, it's all right, just like this. What does this output to the console? Let's do it like that. Well, let's try to get some understanding here. We initialize a variable I to 11. Then we go into this while loop. And the while loop has a condition, of course. It always has a condition. And then it has some operation that gets repeated, which is to increase I by 3. And then when we're done the while loop, then we print I. Okay, so it's going to print a number. So the answer is just going to be a single number, whatever it is, 100, maybe it prints 100 or 200. It's going to print a number here. And notice that this print operation is not inside the loop, it's outside the loop. So it's not printing the number over and over again. So we're just staring at this code here, trying to understand it a little bit. So you set I, let's just try to understand what it's doing. We set I to 11. And then we check, we enter the loop here, we check that I is less than or equal to 99. And it is, of course, 11 is less than or equal to 99. So then we add 3, and then I becomes 14. And then we check the loop condition. And we keep adding 3 and checking the loop condition. So the question is, how many 3's do we add until I exceeds 99? Well, let's see. How many 3's do we need to add? Well, what's the difference between 99 and 11? That's 88. So if I is increased by 88, then it hits 99 exactly. But if I is increased by 89, then it hits 100, and the loop condition is false. So say 89. How many 3's are there in 89? Well, let's see. How many 3's are in 90? 30. There's 30 3's in 90. So let's suppose we ran the loop 30 times. Then we would add 3 30 times. So I would be increased by 90. And then an I, starting at 11, being increased by 90, would be at 101. So when I reaches 101, the loop condition is false. So we don't add 3 anymore. We don't do the loop anymore. But let's check our math there because, well, I don't know if we call it math, but let's check our reasoning. We added 33s. Maybe we went too far. What happens if we added 29 3's? So that's adding not 90, because let's see, 33's is 90, so 29 3's is 87. I suppose the loop ran 87 times, so we added let's suppose the loop ran 29 times, we added 3 29 times. It means we added 87 to I. So I would be, is that 87? 98, right? 98. But 98 is still less than 99. So running the loop 29 times, the loop condition is still true. It means you're going to run the loop more. So when we run the 30th time, we're going to add 3 on the 98, and then I will become 101. I is now 101, and the loop condition is false. So what do we do next?
Print 101.
Yeah, we print I, so we print 101. So your answer on the exam would be 101. You think you can practice those? That analysis that I did? Okay, that's you'll need to do one of those problems on the exam, at least one of those. All right, anything else? Any other problems? The others are pretty straightforward? Maybe you haven't looked at them yet, right? Okay. We can move on to, that means we finished this lab 2. And we can move on to lab 3. I'm going to check something here. The exam is February 9. Okay, I need to print copies of the exam. I need to make a mental note. I need to do that in advance, just like all of you need to start practicing too. All right, so lab 3, algorithms. So we really already started algorithms. The way we just analyzed an algorithm. This is it's a sequence of steps with loops and conditions and branches in it. We just analyzed an algorithm. Before that, we implemented an algorithm to calculate the sum of values through 0 through n. So we're going to continue with that exercise. And pretty much the rest of the class deals with thinking about algorithms and writing them and analyzing them. A little bit of the course is also involved with understanding more about the language and this thing called object-oriented design, which we'll get to later. So exercise 1, detecting prime numbers. Write a console program that asks the user to enter an integer greater than 1. I'm going to do that right now. I'll make a new directory called lab3. I'll copy a program from the lab2 directory just to save time. This is exercise 1. Let's see if we have that working. Oops. That produced a dot out. All right. Write a console program that asks the user to enter an integer greater than 1. You know, I know that I can just get that done now and then I don't have to think about that. You know, it's a console program and it asks the user to enter a number greater than 1. So that's pretty straightforward. Well, we'll need to read it in, I'm sure. So let's go ahead and read that in. Call the integer n. I'll just put a little test here. So we prompt the user to enter the number greater than 1, declare the integer n, read it in from the keyboard, and then let's just print it out. So it seems to be, we got that part done. All right. The program determines if the number entered is prime and writes a message to standard output stream stating whether the number is prime or not. For example, if the user enters 42, the program displays 42 is not prime. If the user enters 47, the program displays 47 is prime. Develop 8 test cases and verify that your program runs correctly for them. The test cases should contain some prime numbers as well as non-prime values. Include test cases that try to break your program so that you are sure you have implemented the code correctly. Include 8 test cases within a multi-line comment near the top of your source code file. Make sure the comment is nicely organized and easy to read and understand. Let's do it like this. I'll put it here. Here are the test cases. So here's a multi-line comment. It starts with a slash star and ends with a star slash. Everything in between is ignored by the compiler. So we'll have a value n, and whether it's prime or not. So say 2, yes. 3, yes. 4, no. 4 is not prime. 5, yes. How about 9? No, it's 3 divided by 3. What about 27? No, that's 3 times 3 times 3. What about a big number? 108. Oh, sorry, that's no, right? 42? No. Should be prime, but it's not. 47 is prime. So I need 8 of these. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's okay to do more, but I guess I'll leave that in there. So we have 9. These are the test cases that we'll try. So when we write the program, after we write it, we'll test it to see if it runs correctly with these values. So we're going to read in a number, and we'll say something like n is prime. It'll look like that. Let's see what it looks like. Oops. Let's see. Anybody see the mistake?
Quotation.
Good. Missing quotation. Very good. $47. 47 is prime. 42. 42 is prime. Oh, so it's not working right, but we've got it a little bit like where we want it. We're heading in the right direction. Okay, let's keep going here. So we'll need some kind of a branch where it'll look something like this. If, something, then print this. Else, print the other one. Maybe it won't look exactly like that, but that's just to sketch it out. It should look something like that. It'll have the same effect. All right, let's figure it out. A number is prime if it doesn't have any divisors other than itself and 1. So can we write that in code? Let's suppose we enter the number 6. N is 6. So what do we do in code to determine that 6 is not prime? What do we do? Well, we find a divisor, right? That's not 1 or 6. we don't want to try to, we don't need to worry about 1 or 6, but we'll try 2. Oh, 2 divides into 6. Well, 6 is not prime. You see? If, well, how do I say that 2 is a divisor for 6? How do we say that in code? Anybody know?
6 modulo 2.
N mod 2. What is n mod 2? If n is 6, what's n mod 2?
The remainder of 6 divided by 2.
Yeah, this is the remainder. Does everyone know this operator here? This is a remainder operator. Take n, divide by 2, and then produce the remainder. And the remainder is 0. So if we divide by 2 and we get a 0 remainder, then it's not prime. Then n is not prime. Otherwise, say it is prime. That's our first guess at what it should do. 6 is not prime. 5 is prime. And 9 is prime. Oh, see, n is prime not because it's divisible by 2, but divisible by 3. So we've got to try more numbers. Well, we don't know how big n is going to be. So we want to try all the values less than n, or less than square root of n, to make it faster. So we need a loop. We're going to need a loop. We've got n, we don't know how big it is. It could be 1,000,000. So we want to try all the values between 2 and that n minus 1. So instead of dividing by 2, we'll divide by I. Take the remainder. If any value I divides evenly into n, in other words, n mod I equals 0, if we find any I such that n mod I is 0, then we know that n is not prime. Otherwise, n is prime. I'm going to tell you that this code is buggy. And my experience in this class is that half of the class will write the code this way, at least. Do you see the error in the logic? Every quarter, I get at least half of the class that does this solution. There's an error in the logic. Why does this fail? Let me prove it to you that it fails. All right. Oh. It never exits, right? It never exits. As soon as we determine that, n is not prime, we can break from the loop. So that's the break statement. That means exit the loop that you're in, the most closest loop that you're under. And 9 is prime. Well, it's still wrong, right? You see the problem with this logic? This is I'm going slow on this because so many students don't get it here. And it's not just this problem, it's similar problems. This problem will come up over and over and over again. We're looking at a lot of different cases. I goes from 2 to n minus 1. We're looking at all those cases. If we find a value I that divides evenly into n, we know right on the spot we can declare that n is not prime, and we're done. We don't have to look at anything else. But we cannot conclude that n is prime. We have to look at all the values for I before we can make that declaration. So this piece of code here needs to come out. We have to look at all the values for I. We have to make sure that no value for I divides into n. At that point, we know that n is prime here. But here, look, if we print this and then break, then we're going to end up printing this line as well. N is not prime is correct, but we still print the last line. How about if we put a prime number in there? That works. So if we print that n is not prime, we don't want to print that n is prime. Here's one way to do it. Let's do it this way. Let's create a boolean variable. And I'll call it is prime. And we initialize that to true. And then when we find a divisor, we know that the number is not prime, so we'll set this Boolean variable to false. So this is a data type, it's called bool. It means the variable is prime, stores the value true or false. Initialize it to true, and we assume that the number is prime. When we find a divisor, we're going to reverse our hypothesis. We'll say, well, we were wrong, it's not prime. So we'll set our is prime Boolean variable to false. Although we could. I'm going to do it out here. Once we're done the loop, we'll check to see if this variable is true. If is prime is true, then we'll print that n is prime. Else we'll print that n is not prime. I'm going through the test cases here. I think that's all of them. I think 8 is a good test case too. Okay. There's other ways of organizing the code. This is just the way I did it. We used a boolean variable. So, any questions? No, it's okay. All right. Let's take a look at the next exercise, exercise 2, listing prime numbers. Now what we need to do is to write a console program that reads a positive integer entered by the user. The program computes and displays all the prime numbers between 2 and the number entered. To solve the problem, you need to nest an inner loop within an outer loop. Develop test cases that include them. Develop test cases and include them in a multi-line comment. All right. So here's the input, and this would be the output. Let's check, make sure we understand what it's asking. Display all the prime numbers between 2 and the number entered. Does it include the number entered? It doesn't say, but I think we can just do it and include that. I'll do one more. Nine, 7, 8, 9, 10. They're all, well, then it would include 11. So if you entered a 2, all the numbers between 2 and 2 that are prime would be just 2. You enter an 11, all the numbers between 2 and 11 that are prime are 2, 3, 5, 7, and 11. Okay, let's write a program that reads that value n and then produces that output. I'm going to say enter an integer greater than 2. Or greater than 1. I guess it was okay, greater than 1, because we should allow it to take a 2. It's good. The 2 is good. So read in the end, that's great. Now, this loop here determines whether n is prime or not. How about if we do this? Let's change this to k. See that? Let's change that value to k. So we're going to read in the value k. And then what we want to do is let n start at 2 and go up to and include k. And in this loop, if if n is prime, then print it. That's it. That's all we need to do, right? We start at 2. If n is prime, then we print it. And we let n start at 2 and then go all the way up to k and include k. So we're repeating. Well, how do we determine if n is prime? Well, we have that code here. Look, just right there. So we can just take this and just put everything on the inside of that loop. Oh, wait a minute. We don't need to print this. If n is prime, then we'll print it. If it's not prime, we don't need to print anything. Of course, when we're done, we'll want probably to print some kind of a new line here. You see how I'm working this out? I wouldn't memorize this. I would get the feeling of how I'm solving a problem. Look at how I am crafting the code, kind of like you're making a sculpture. You've got a chunk of clay and you're molding it and looking at it take shape and form. That's what it's like. It's not like you just get it and write it down. You've got to work with it. It's like building a house. You just take time and you get your equipment, you think about it. Well, it's not exactly like building a house. You've got a lot more flexibility to try things out and go in different directions. More like sculpting with clay, maybe. That's a better analogy. But don't just take a picture of this and then put it down and submit it as your lab exercise. That would be a total waste of time. You've got to go through the process of thinking through this problem, the solution to the problem. You must practice that. That is if you want to do well in the exams, and then after that, if you want to do well in later courses that require programming, if you want to do well in a career that requires programming, and there are many careers that many of you will get engaged in which require programming. So you need to practice this. It's not just a matter of submitting the right answer. That's not going to help you much at all. All right, so let's see if we got this. Enter a number greater than 1, 6. Before I hit enter, what is it supposed to print? 2, 3, 5. Right? Those are all the prime numbers less than 6. 2, 3, 5. It works. Let's try another one. We had 11. 11 was another test case, wasn't it? That works too. Let's do all of our test cases. 2, 3, 4, 5, and 9. 2 works. 3 works. 4 works. 5. What was it, 9? Yeah, these are all working. Now this program, the code here, as you see it, is it's not bad. It's acceptable, but it could be cleaned up a little bit. Let me clean it up a little bit. I'll take that comment out. And this Boolean value, we can make this code work without this Boolean variable. Let me show you how to do it. At this point, we know that I is prime. I'm sorry, n. N is prime. At this point, we know that n is prime. So we can just print the value right there. We don't need to check it here. Look at that. I added this line. I added one line. And I took out 5 other lines. I took this one out, and these 3 out. Plus a blank line here. Take that one out too. Let's see if it still works. Looks good. Wait a minute, it's not good at all, is it? It should print 11. Did I get that wrong? Something's wrong.
Those are also not prime numbers.
Oh, they're all wrong. Oh. We can't do it like this. I got it totally wrong here. At this point, so we need this variable actually. I got it wrong, totally wrong. We need this. Is prime as false, and then we break here. Oh, we need that, sorry. I don't see, how can we simplify this? I think we have to do it like this. Not exactly, let's see. No, that didn't work. I'm looking for a way to make it simpler. It's nice to get rid of the Boolean variable if possible. But it might end up being more messy. So maybe I'll just leave it like this. Oops. What happened?
Still have it up there before
Nothing
it is
works.
prime. The C out's above is prime.
Oh, there it is. Thank you. All right, back to normal. All right. You see what I did? I tried to simplify it. That's called refactoring. I wanted to improve the readability of the code, so I spent some time trying to clean it up and to reorganize it. And I think this is pretty good. This is fairly readable. All right, let's go to the next problem here. Factoring numbers, then generating random colors. I don't really want to do all the problems for you because you really need to struggle with these too, right? But this factoring numbers is, that's pretty tricky. So maybe I'll let you work on that a little bit. I won't cover that. And generating random colors. Did anyone do this yet, factoring numbers? You did this already?
Yeah.
How long did it take you to get it?
5
5 hours?
couple of hours.
Couple of hours. Couple of hours. Okay. That's good. You could do it in a couple of hours. That's great, really. This is worth struggling with. I mean, now, like, your ability to write code to derive algorithms is really, improve so much with that effort. That's what you need to do. A couple of hours on this. Even more if you don't get it. Learn how to do this stuff. And what about, did you do this one, generating random
I
colors?
can't figure this one out.
Can't figure it
I
out?
stayed a couple hours just trying to figure it out. I couldn't.
A couple of hours, all right. Maybe I'll do this one then. Although it is, it's, how many days until we have our exam? Anybody know? How many sessions do we have between now and our exam? No, February 9.
3.
3 sessions? It's the 26th. It's still a ways away, isn't it? All right, let's see here. We won't solve it all the way. I'll just talk about it a little bit, maybe. Okay, just to get people oriented. Write a program that generates a different list of 100 random RGB color values using hexadecimal notation. The program should write something like the following into cout, like 3248F3. That's a color value, a 6-digit color value, using hexadecimal notation. There's 2 and then 98 more, so there's 100 of those. To solve the problem, you need to generate strings with 6 characters. Each character is randomly chosen from the following set of symbols. To make the choice random, you need to use the modulo operator. Specifically, use the expression rand mod 16 to get a random integer between 0 and 15. See, this will be 0, 1, 9, 10, 11, 12, 13, 14, 15. So we have 16 possible random numbers in decimal notation. We just simply translate that into hexadecimal notation. So if we get a 15, then we'll print an F. We get a 14, we'll print an E. We get a 1, we'll print a 1. To solve the problem, you need to define a loop within a loop, just like the problem we just looked at. You can solve it without a nested loop, but that's something we're going to do later on once we get to functions. So I want you to work on understanding nested loops at this point. And we haven't introduced functions yet. I mean, we did talk about them a little bit. We want it to generate a different list of color values each time it runs. All right, let's take a look here. So here's some sample code. What was that? C time. All right, there we go. So we want to use the random number function, the random number function to generate random values. Say int n equals rand. And we print the n. So we run it, We get a pseudo-random number. We get the same number each time, right? We need to seed the random number generator. So we use srand, pass in the number of seconds from some epoch, that's time 0. Now we get a different random integer each time we run it. Okay. So but what we want to do we don't want to print a random. Let's what we need are random hexadecimal digits. So to move in that direction, let's do as suggested in the problem end. Take mod 16. So we have this big random integer returned by rand. And then we'll divide it by 16 and throw away the quotient, just take the remainder. Let's see what it looks like. 12, 10, 1. See, it's good. But actually, we don't want to just print n. Well, we can print n if n is less than or equal to 9, let's just print n by itself. That's a hexadecimal digit. But what if n were to be 10? Then we would want to print a. And if n were 11, or 12, or 13, or 14, or 15, this is F, E, D, B, and C. So if we get 10 as our random digit, our random value rather, let's print the hexadecimal digit A, and so on through 15. Just going to clean that up. Just to line these up. So we generate a random integer n. And use that random value to produce a hexadecimal digit. Look at that, hexadecimal digits. 0 through F. I hope we get a 0. We need there's a 0. 0 through F. But we need 6 in a row. So this should be in a loop. Right? I'm going to put that in a loop. So we want to do 6 in a row. Look at that. Those are Random color values. And we need to run it so we get 100 of them. You know how to do that? Put it in another loop. There you go. So that's one way to tackle this problem. I mean, at this point in the course, given the material that was covered in the book, that's how you would do it, because we haven't gotten the functions yet. And that would be another way to do this. Also, we haven't done arrays. We could have used an array to store the hexadecimal digits and then index into the array and print the digit from there. Lots of different solutions to the problem. All right, so I think that's it for today.